me, Shubhajit Shah. Welcome to our YouTube channel Helm of Science. Today's our topic is factorization. In this class, I will first listen that this topic factorization is not only important for class 9 or 8, but it is also important for class 10 because this factorization helps you. Some of the in class 10, some of the question is directly related to factorization, but also some of the problem is the intermediate. That means what is the intermediate? Some if you they will give some problem, their factorization can takes place. So you applying factorization, you will solve this problem. So you have to know the factorization very well, right? That like I will give you some name of chapter. The factorization chapter is reminder theorem. In class 10, reminder theorem is not actually chapter of factorization, but you have to do factorization. Like if you don't do the factorization, you cannot solve any problem on the basis of a reminder theorem. So listen very carefully and note the very carefully whatever I will do in this class. So first, what you mean by a factorization? So we all did some in class 3 or 4 a prime factorization. What is prime factorization? Suppose if I factorize 50. So what happened? How will we do prime factorization? Suppose 50 is 2 into 25 divided by 50 by 2. Then 5 into 5. So I can write the 50 equal to 2 into 5 into 5. Fine. So 2 and 5 and this 5 I can call they are the factor of this 50. Fine. I again repeat, these 2, 5 and 5 is a factor of 50. So I can say if I factorize 50, we get the three factor 2, 5 and 5. So what actually if I try to convert this data with a sentence, what outcome will take place? So the expression, when an expression can written as any expression, suppose A into B can written as product of two expressions, suppose A and B, or 50 can be a product of 2 into 5 into 5. So when expression can expressed as product of two or more expression, then this process is called factorization. That is clear, very clear all of you. First of all, what did I do? First, I factorize 50. We get 2 into 5 into 5 or A into B. So I have told that any expression can be written as product of two expression or more than two expression is called factorization. So this is the basic factorization method. They are the basic factorization method. This concept will be classified more classified in various states. So after that, this is the definition of factorization. After that, I will show you what are the processes of factorization, in which processes use the process of first process of factorization. First process is factorization of is taking out of common part. What does it means? Taking out of common part. So what does it mean? I will show an example and prove that. Suppose 9x square plus 12xy. So this is a mixing problem of constant and variable, where 9 and 12 are constant, x, y are variable. Fine. Now what is the procedure of taking common in both terms? Fine. So I will show you. First, look at the variable very carefully. 9 and 12. What are the common term in 9 and 12? What are the common term in 9 and 12? In 9, we get 3 into 3. In 12, we get 3 into 4. So in this case, 3 is a common factor. Fine. So in between 9 and 12, 3 is common factor. So I can remove or taking out the 3 from these two terms. Fine. Next, in this case, x square can be written as x into x. Fine. And y x into y can be written as x into y. So between this, x is a common term. Excuse me. X is a common term. So we can taking out the x from for this term. So finally, we actually taking out 3 and x from the both term. So if you common this 3 into x, so what is the remaining part in 9x square? So if I divide 9x square by 3, so what will 3x, what will get? Because we taking out this common part now. So what will we get? X cancel out, 3 cancel out. We have remaining, we having 3x. Fine, we have 3x, and in this in this term in 12xy we have 4 into y. So finally, this 3x into 3x plus 4y is a factorization of 9x square plus 12xy. So before earlier I said that the factorization is the product of two expressions. So what is the expression in this case? 3x and 3x plus 4y. Thus this is the true expression of the 9x square plus 12xy. So 3x into 3x plus 4y is the factorization of this term. So this is a very simple example, and I will show you another simple example. Then I will go in complicated part. Okay, fine. So I rub it all the term, and I will go to problems. So our next problem is, so our next problem is 36x cube into y 60 x square into y into z. Fine, this is our next target problem. So in this problem, what is the variable and what is the constant? 36 and 60 are constant. X and y and z also are the variable part. So what is the common part between 36 and 60? So 36 can be written as 6 into 6. Fine. And 60 can be written as 6 into 10. Fine. So this 6 is the common part. Fine. Again, this 6 can be written as 2 into 3, and this 60 can be written as 6 into 10 can be written as 2 into 5. So if I break properly, it's 36, 6 into 2 into 3, 6 to the 12, 12 to the 36. Fine. And in 60, 6 to the 12, 12 5 to 60. Fine. So what are the common part in this? This 6 into 2 are the common part of this constant. So we have to taking out 12 from this expression. We're taking out 12 first, common this expression. Now what is x cube and x square yz? In case of x square, x cube into yz, and x cube into y, and here x square into yz, we get common part x. We have x square into xy, we can write it written as this, and we can written also x square into y into z. So this x square and this y are the common part. So we have taking out x square y in from both terms. So we take x square into y. This is the common part of this expression. So what the other terms remain? So, if I take 12 from 36, we get 3. Fine. And if I take x square into y from x cube y, we only get 3x. Fine. And here, if 60 is divided by 12, then we get 5. Okay. And if I take x square into y, so this time will totally remove and only z will remain. So this is our final expression, 12x square into y in bracket 3x plus 5z. This is our factorization of this expression. Got it? So I remove this problem. If there is any doubt, you can ask me in the comment section. I try to resolve your problems. So now next problem is little interesting problem. Not hard, but little interesting. Right? Okay, this is our problem. So first, what is our constant? 8 and 10. 8 and 10. So 8 can be written as 2 into 2 into 2. 2 to the 4, 4 to the 8, and 10 can be written as 2 into 5. So what are the common terms in 8 and 10? Only one common term is present, that is 2. Fine? There is only one common term. So if I taking out 2 from both terms, we have to get this 2. And now listen very carefully. Here 3a minus 2b whole square is present, and here 3a minus 2b is present. So suppose if I write 4, what I can write? 2 into 2. Is it not? Is it? So 4 can be written as 2 into 2. So a square term can be written as is multiplied. So here 3a minus 2b whole square also written as 3a minus 2b into 3a minus 2b. Like 4 is written as 2 into 2. 3a minus 2b whole square equal to 3a minus 2b into 3a minus 2b. And here only one 3a minus 2b is present. So what is the common part? Common part is 1 3a minus 2b. From here we remove or we taking out 1 3a minus 2b, and here only we have 1 3a minus 2b. So 3a minus 2b is the common part. Fine. We have 3a minus 2b common part. So what happens? If I divided 8 by 2, what we will get? To 4. The common part, remaining part is 1 3a minus 2b. And here only minus 5b, because this will taking out from this expression. So 2 into 3a into 2b sorry for the interruption. So what is the remaining factor? 2 into 3a minus 2b into 4 into 3a minus 2b in bracket minus 5. So if I will open the bracket, what will get? 4 into 3, 12a, minus 4 into 2, 8b, okay, minus 5. So the final expression is 3a minus 2b into 12a minus 8b. Okay, these are the three expressions. So in this expression can be written as a product of three expressions: 2 into something into something. This is a little tricky, not tricky, very interesting question. So I will show you another example, and this is the last example of this process, is taking out of common factor. So in this expression we have x into x minus y whole cube plus 3x square y into x minus y. Look at very carefully in this problem. There is no constant present except 3. Sorry, there's 3. There is no constant present, but this 3 will not gonna common can be anyway, because in one expression there is no constant, and another expression only one common constant in present, that is 3. That 3 will not hamper, or that will not involve in our factorization process. So if I write x into x minus y whole cube, what we will have get? Suppose we have a cube. Okay, now a cube can be written as a into a into a. Fine. And so x minus y whole cube can be written as x minus y into x minus y into x minus y. Fine. So x minus y whole cube can be written as x minus y into x minus y into x minus y, and there is only one x minus y is present in this section. And if x is present here, then this 3x square y can be written as 3xy into x. Find this 3x square y written as 3 into x into y into x. So x is a common part in this, and x minus y is a common part between this and this term. So common part is what are the common part? X and x minus y. Fine. So remaining part, what are remaining? So if in three terms one is taking out, so remaining portion is square. So our remaining portion is x minus y whole square plus x minus y is taking out and x is taking out. So remaining part is 3 into x into y. Fine. So x into x minus y. Before this class, I will give a lecture on expansions. There I will show you the breaking of some formula. So what is the formula of this a minus b whole square? This is look like a minus b whole square, and what is the formula of a minus b whole square? A square minus 2ab plus b square. So x minus y whole square equal to x square minus 2xy plus y square, and here plus 3xy is present. So our desired factor are x into x minus y into x square plus y square plus 3xy minus 2xy equal to minus xy. Got it? This is our final result. This is a good question. So by helping of these 3 or 4 problems, I showed you that how common factor is the process of factorization. So after that I will go to next process of factorization. So our next process is grouping. What is grouping? Again I will show you an example and clear the concept of grouping. So first problem is x square plus y minus xy minus x. So we have to take two terms as a way, so we get a common part in both terms. Again I repeat, in this process, grouping process, we have to take a common part or a grouping such a way we get a common part in both terms. So what is the meaning of this statement? Suppose here what are the terms in present in this expression? X square, y, xy and x. So I will try to take a grouping that will help you to get a common factor. But suppose I have write x square and minus x in one group, okay, and take minus xy and plus y and another way. So here we have to take the similar terms. What similar terms? X square x, and they are similar terms. In these two terms only x is present, and this x minus xy and plus y, in only y is present. So we have to take the group or group wise the similar term. We have to take a choice a group of similar term. So we have to take a common part. So if I will take a common, what is the common factor? X square minus x. X square can be written as x into x, fine, and x can be written as into x. Okay, so in this complex we take x. So what is the remaining part? X minus 1. Okay, this is the remaining part, and from that we get minus y common part. So we have x minus 1. So grouping a same species, x square minus x and xy minus xy plus 1, we get a common factor in both terms, that is x minus 1. So we can write this x minus y and x minus 1. So this is a common part, x minus 1, we taking out from x minus 1 common part, x minus 1, and remaining part is x minus y. This is the actual process of grouping. This is another application of taking out the common factor, but this is slightly different because we have to take a or we have to choose a group. In this case, we have to choose a group. So this is the first problem. After that, I will show you another two examples. Then this grouping process will get clear to all of you. Our next problem is a square plus 4a plus a plus 4. Now see very carefully. Here three terms are common. As that is, in this expression, three terms have a and only one type of a constant. So how will you choose a two terms? In this case, term will choose like we get a common factor. Suppose I will take a square plus a in one side and 4a plus 4 in one side. Okay, so what will we have? We have a into a plus 1. If I take common, taking out the common a, so we have from this a and from this 1, and if I take common 4, then what will remaining part? A plus 1. Look very carefully, this a plus 1 is a common factor of both terms, so I can choose a group like this one. Okay, so I can choose a group like this one. Fine. So what will our result? A plus 4, a plus, if I take common a plus 1, so what will the remaining portion? A plus 4. So this is our desired result. So this is one way of grouping. Can I do another way of grouping? Yes, we can do another type of grouping. What is this? Look, here I rub it. Here a square plus 4a is the one term and a plus 4 is another term. Fine. So if I take taking out a common factor of a, what will the remaining portion? From here a is taking out, so a is remaining, and from here 4 is remaining, so a plus 4. And if I take 1, suppose a plus 4, if I take 1, suppose any number can be written as 1 into a, 4 can be written as 4 into 1. So 1 is the common part from all every term. So if I take common 1 plus 1, so what will get? A plus 4. So this again a plus 4, here a plus 4 is a common part. So our result is same, that is a plus 4 into a plus 1, but grouping is different. So when the grouping is right, where we have get two common part from each grouping. So this is our final result. Fine. And finally I will show you this example, that this grouping problem is clear to all of you. Six AB minus B square plus 12AC minus 2BC. This is our problem. Okay, so I have to choose first a group. How I do? If I take 6AB and 12AC in one side and minus B square and minus 2BC and another group on another side, because in these two terms B is present, in these two terms A is present. So it's just these are the common part. So if I take common, what is the common part between 6 and 12? This 6 is a common part. So if I take 6 and here is A is also present, here A is also present. Okay, fine. So we will get B plus 2C. Okay. So how someone get b plus 2c from minus b square minus 2bc. That is our target, because we have to take out a common factor. So question is, how will someone get b plus 2c from minus b square minus 2c? Listen carefully. Minus b square can be written as minus 1 into b square, fine, and minus 2bc written as minus 1 into 2 into b into c, fine. So here comes to the common part. Listen very carefully. Here this minus 1 actually common, here this minus 1 actually common, and this b is actually common. 1b is present in here also. So here 1b is common, here only 1b is common. So minus 1 into b is a common part. Excuse me. Minus 1 into b is a common part. So what is the remaining portion? B. If here I take minus 1, so this minus will not present. So what we have? Plus b. So here 2 into c is present. So we will get the common part. So what is our result? 6a minus b and b plus 2c. This is our result or answer. So this was grouping problem in or I can say help of grouping. We can factorize all those three terms. Then now I am showing you a good example or good problem how taking out common factor and group will do together. So this is our final example of grouping process and also taking out common part process. So what is our problem? X square plus 1 by x square plus 2 minus 2x minus 2. First listen very carefully. Here the expression of a plus b whole square will take a very major role. Suppose if I write x plus 1 by x whole square, what we will have? What is a? X is a and b is 1 by x. So first is x square, that means a square, then plus b square, that means 1 by x square, that is b square, and what is a 2ab plus 2 into here x is a, okay, and 1 by x is b. So from x plus 1 by x is whole square equal to x square plus 1 by x whole square plus 2x into 1 by x. Okay, now x cancel. So we have x square plus 1 by x square plus 2. So from x plus 1 by x square we have this term. So this application, this process will help in this case. Look very carefully. This is a set of this x square plus 1 by x square plus 2 minus 2x by 2 minus x. So this can be written as x plus 1 by x whole square. This can be written as x plus 1 by x whole square. I have shown you. Now what is the remaining portion? Minus 2x minus 2 by x, minus 2x minus 2 by x. So what is the common part in this case? Minus 2 common part. Okay, so what is the remaining portion? If I take minus 2 from these two terms, we have x plus x and plus 1 by x. Understand this from up to this we all understand. I can take into this term. From this term we have actually this simplified form. So now this is not actually a problem, actually not based on factorization. This is, we have taken just a simple step, that is the common factor, but this is example of this is a problem based on expansion. So before the class I have said that the expansion is a very important. It will show you in everywhere, that it helps you in everywhere, in every problem. So listen with, you can look at this form of expansion formula, how we can solve this problem easily by using this. So now, okay, now I come to our problem. So what I have, x plus 1 whole square minus 2 into x plus 1 by x. From this I am writing it. So now what is the common portion? This x plus 1 by x is present in both cases. So x plus 1 by x is the common portion. So what we will have? X plus 1 by x minus 2. So x plus 1 by x into x plus 1 by x minus 2 is the factorization of this term. I think everybody can understand this problem. So this our the final problem of grouping method and taking out of common factor method. Now I will show you a process of factorization where a square minus b square formula will take a major role. So the third process of factorization is based on this expansion formula, a square minus b square equal to a plus b, a minus b. This, so in next day we will discuss the factorization based on the formula a square minus b square equal to a plus b, a minus b, and another concept will come in this picture, that middle term factor. If some expression is given, then you have to fit the middle term in such a way that we can analyze or we can develop a form where a square minus b square is produced. So in the next class we will discuss two important topics based on factorization. One is a square minus b square and another is middle term factor. This middle term factor, the next class is too much important. This class is also important, but next class is more important, because this after middle term factor concept will help you not only from class 9, this will help you from class 9 to class 12, or more than that. If you go BTech, graduation, whatever it is, the middle term factor is the most fundamental tool of mathematics. So you have to see the next class. So for today's class this is enough. If you have any doubt about in this class, you can ask me in the comment section, and try to keep practicing every math whatever I have solved today, and subscribe our channel.